also we are going to look into it. Probably we are going to look into a little bit of Hunt's algorithm. Hunt's algorithm is something which you have already seen, okay, in one of the examples which I have given as a decision tree, but we are going to see in terms of the steps what they have given. Okay, we're going to see in that way so that it becomes very easy. Okay, you already know it because we have already seen such an example. Just going back and looking into from a Hunt's algorithm perspective. Okay, so this is the example we took to figure out, the decision tree aspect of it. What is it? It's a basically for a mammal classification, right? We started from body temperature. In body temperature, you have two parts: warm-blooded and cold-blooded. In warm-blooded, you got again have two parts of it. Okay, what is two parts? If the animal is giving birth to it, okay, if it is yes, you call them as mammals. If they are not giving birth, okay, directly, if they are sort of laying eggs and all, you don't call them as mammals, but you call them as non-mammals. Okay, and then you see those leaf nodes. Okay, that is been assigned to the non-mammals, which you see right at the top of it. Okay, see, this is something that we sort of understood. Okay, based on that, if you can sort of explain this, this is what you're going to get. Okay, temperature is used to separate warm-blooded and cold-blooded things. Okay, good. Next, since cold-blooded vertebrates are non-mammals, the leaf node of it, okay, now non-mammals is created right at the right child of it. Okay, how decision trees are basically getting created. That's the answer for it. Okay, next, if the vertebrate is warm-blooded, subsequent attribute. What is subsequent attribute? Gives birth. How does it give birth? Will it be giving it directly, or is it giving it by laying eggs like birds? Based on that, classifying a test record is straightforward once a decision tree has been constructed. See, once you know the decision tree of how it is constructed, right at the end you can clearly say whether the particular decision can be made easily or not. Okay, the most simplistic way of looking into decision trees. Okay, now starting from the root node, we apply the test condition to the record and follow the appropriate branch based outcome of a test. So you see an internal node and you see a leaf node. Internal node will be asking for condition, asking or checking for a condition. Leaf node will be giving you the results. Right? Leaf node will be giving you results. The internal node will be checking for a condition. Okay, so these sort of things need to be kept in mind. Okay, so let me sort of go into a little bit into it. Okay, so what is it basically? If you take this an example, okay, if you take this example, I have take one more example for it, so don't worry. This is all from your textbook. You see this, black and white diagrams. Whenever you see that, you should always believe the fact that this is right from the textbook. Okay, because we need to embed things from the textbook also in your notes or PPTs only. Okay, I can't take every time the different thing. When you say something in color, probably it's not from textbook, but somewhere else. Okay, but of course the concepts need to be same for your understanding of it. Okay, so let me again go back into this. What are the things that we are sort of looking into it is, okay, now you see this example. We are talking about a flamingo. Flamingo is the name of a bird. Okay, it's a bird that basically stays or lives near a water shore. Okay, when I say water shore, the water bodies, lakes, big lakes, or a water body which has marsh water bodies, such places. Okay, you can always Google it. It's a very beautiful bird, flamingos. Okay, now you see this is with regard to, we don't know whether what class to be put into this. Okay, with regard to flamingos, so what we do, we go for a decision tree. We start ask for what is the body temperature. Is it warm-blooded or cold-blooded? So we say no, it's warm-blooded. Okay, then we say we come to gives birth. Okay, we ask whether the flamingo, we don't know whether it's a bird or not. Okay, we just know its name flamingo. So we say this flamingo, right? Whether it gives birth directly or will it be laying eggs? So we say no, it gives birth directly. No, it's not going to give birth directly, but basically it is laying the eggs. So what is a thing that we can deduce from it? We can easily deduce the fact that it is a non-mammal. Okay, it's not a mammal, it's a non-mammal. So you can put that very class right here, that the last thing that you got. See, our job here is very simple. Okay, put either in mammal or non-mammal, good or bad. Okay, So, but there are very various shades, right? When this is for only binary values, mammal or non-mammal, but with the various shades of it. Okay, there's no good and bad. There's no black and white, right? There's lot of other things that people sort of come across also. Where is it? Yeah. Okay, there's various other things that people come across, right? It's not just good or bad. It's not just white and black. There's something called gray, right? Something called gray area. What do you call people when people will say about gray area? What do you call it? It's between your good and bad. It's between your pure and impure. Okay, I don't know how many of you know it. There's a very famous book called 50 Shades of Grey. I think it was made into a movie also. Okay, people who have read it, people who have seen it, good. Okay, very famous movie. I think if I'm not wrong, around 5 years back. 50 Shades of Grey. Okay, if you've seen it, good. If not, please do check it out. Okay, but it contains a little bit of explicit scenes, so you got to be careful. Okay, of watching it with whom you want to watch or not. Okay, so what is the next thing that we look for here? Okay, there's so many things like that. Okay, say I don't know. Okay, once you sort of step into your final year, people will be asking you to donate books to the college. Okay, the department library to be precise. At that time, okay, we'll be making sure that if you guys are too much into books and all, so one book right from the curriculum aspect of it, like any test books which you people have used it, and one more test book. Okay, not test book, any other book. Okay, which you people will be reading it. Okay, or you feel like it should be donated. Those things can be given and all. So I hope people who are bookworms, they'll be having lots of books to be donated to the library. Okay, anyway, that's in final year. We'll see that later. Okay, so what is the next thing that we see here? Okay, this is an example for how we are going to do it with regard to just by not having the class, we are going to put that particular non-mammals into a particular class here. Okay, same thing is being done in the next few examples. Okay, keep that thought with you. We are going to come back to it. Okay, so how to build a decision tree? Basically, there are many ways that you can build a decision tree. Okay, many ways. Once you step into machine learning, you'll get to know that the very first thing that you're going to learn in machine learning is with regard to ID3 algorithm. There's an algorithm called ID3, okay, which is based on decision or decision trees. That also I've put it in a slide. Okay, you will be seeing that the first thing that you're going to come across is ID3 in machine learning. Tomorrow you have what is it? Machine learning, webinar and all. Make sure that you people are attending it. See, it's very important for you people compared to maybe your second sem or fourth sem people. They have another 1 year or 2 years to go, but you people have only 2 or 3 months to go when you start studying machine learning. Okay, you have just 3 months to go when you start studying machine learning. So make sure that you people are getting to know at a little bit of it tomorrow. Okay, the webinar, whichever I have posted. Okay, Pankaj madam will be there. So make sure that you people are attending it. Okay, otherwise the third and fourth or whatever that is there will be marked absent, and we are at the very dead end of our not dead end, almost very much to the fag end of our semesters. Okay, don't get into trouble when it comes to attendance. Okay, so there are very many ways of building a decision tree. The first one is ID3, Hunt's algorithm, which you are going to see. So many are there. We are not going to worry about the names of it now. Okay, finding the best tree, optimal tree. Optimal means best tree, best solution, optimal solution. Finding the optimal tree is computationally infeasible. Why? Why it is infeasible? Because of a very simple reason, that the size will be decided based on, or the tree will be decided based on the size. And for each and every size, different sort of trees can be built. To say which one is the best one is a very difficult task. Okay, each and every tree will be coming in with its own advantages and disadvantages. Okay, so to say which one is the best is a little bit of a tougher task. Okay, now next thing you can see very clearly that to induce a reasonably accurate optimal decision tree, there are certain efficient algorithms. Now you know where I'm going through from here. Okay, there are certain efficient algorithms which will be giving you the best, what you call decision trees. Okay, these algorithms usually employ what? Greedy technology, greedy strategy, greedy method. So way back 1 year back in DA, you would have learned about greedy strategy or greedy method. Okay, various algorithms also you would have learned. Okay, what were the various greedy strategy algorithms? Okay, we started something called a prims. Okay, Kruskal's, which talked about minimum spanning trees. We talked about tree structures, I think. Okay, all pays shortest path, right? That one. Okay, all those things came across greedy technology. What is greedy technology? First of all, what is a technique called greedy method? Greedy method is used for figuring out the optimization techniques. What is optimization? Figuring out maximum or minimum. What is maximum minimum? Maximum profit, minimum cost, maximum money, minimum loss. Like that. You're trying to figure out the optimization aspects of it. So only you can see right on the top that we are talking about the optimal decision tree. So obviously we come across greedy strategy. Okay. What is greedy strategy? There are certain process of way of doing it. See, what is the difference between a greedy strategy and a dynamic programming? Both you have raised in fourth sem. Greedy strategy talks about a predefined set of steps, which you'll be keep on doing it till you find the solution. Okay. And what is dynamic programming? You're not going to follow the steps. You figure out all the possible solutions for a particular program, and then you say, in this, which is my best, that will be my best solution. Okay, so both are optimal strategies only. Both are doing what is known as figuring out the best solution only, but the way of doing it is little bit different. Okay, so all these algorithms, whatever you're trying to see here, we are all are going to follow the greedy strategy. What does it do? Making a series of locally optimal decisions about which attribute to use for partitioning the data. Okay, now what are those things are there? Okay, before we move into what are the different types of algorithms there, I put the same old thing right here. Okay, same example of the decision tree right here, just to make sure that you people come across of this same old example, because we are going to use this example under Hunt's algorithm also. You will be seeing the same example only at that time also. Okay, see, this is my training data, and this is my decision tree. Okay, I told you many times that a particular training data can have more than one type of decision tree. Here we have taken the root node as right from homeowner. No yes, no yes only it is going to come. Okay, and one thing that you can easily make out right from here is I'm splitting attributes, taking homeowner as my root node. Okay, very important example, very important diagram. Why? Because you're going to learn the same thing in Hunt's algorithm. Okay, Hunt's algorithm, they are going to ask you to explain, okay, theory question, very minimal amount of times. I don't think so they have not asked also, but we are going to do it. What if they give only input? What if you want to draw an Hunt's algorithm? Can you do it? Yes, we are going to do that also. So we'll going to sort of go with our textbook aspects of going only with the theory, and also we're going to take a couple of other examples, and we are going to write an Hunt's algorithm based decision tree. Okay, so that will be used for both of the things. Okay, always prepare for the worst of question papers. So let's go into it. Okay, so what is it? Another example of writing the same old data decision tree. Okay, you can see very clearly here they have made it right from the marital status. In the previous example, they have taken the root node as homeowner. In this example, they have taken the root node as marital status. Okay, and decision trees will vary. See which one you say which is a better one. Both the things are giving you the same old thing only, which is to figure out whether a defaulted borrower is there or not, and who will be the defaulted borrower. Okay, same thing only it's giving, but which one is the best? You don't have to worry. Okay, that's the first slide that talked about that finding out the best solution will depend on the input. Okay, and based on the input, decision trees will be drawn. So it's highly infeasible to figure out the particular solution. But there are certain efficient algorithms that are there, which you are going to study. One, obviously, you are going to study in this semester. Second one, ID3 algorithm, you are going to study in 7th. Okay, like that. You need to keep on linking things, knowing things like, okay, where I've studied this, what needs to be done. Then only, the subjects engineering will become easier. Otherwise, it will be more like a, very dry aspect of looking into things. Okay, nothing. Once you study 6 sem, it's over, it's over. You will not know anything, once you go into 7 sem. That should not happen. Okay. Now, applying the models is the same thing. Whatever the Flamingo example I took, right? The Flamingo example I took, For the same old thing, I'm going step by step. I think I saw show you this even before the internal also. Okay, so just look at it. Okay, apply the model for test data based on homeowner. Okay, where you go homeowner, check if it is no, then you go for no. If marital status clearly says married, so you go for married, and then say you go for annual income that clearly says annual income is 80K. Okay, then you figure out whether, see, there was there a need to go from marital status to annual income? No. From marital status, I've directly gone for figuring out my defaulted borrower, who says clearly is not a defaulted borrower. Okay, what is defaulted borrower? Person who takes the loan but will not repay. Okay, now you may think of this very fancy words called defaulted borrower and all. Okay, it simply means that people who take the loan but they will not repay. So it's called defaulted. Defaulted means he's not able to pay it. Okay, borrower is someone who took the money. Okay, so this is what you get. And what is a way of modeling this? You are going to put that entire thing like this. Okay, change the entire learn model, everything is going to be put like this. You first take the best decision algorithm, you make that algorithm to work, and then based on that you are going to write what is known as the model, the best decision model and all. Okay, this you got to keep in mind. Now I told you very clearly that very efficient algorithms are very tough to come by. Okay, but even then people have figured out few of the algorithms which are very good. How did they figure out? I don't know. Okay, even you also don't know, don't have to worry. If you go too much deeper into what is algorithm, why it is best, the time complexities, everything and all. Okay, when you then you'll get to know why it is best and all. Okay, now as of now, what is the thing to be kept in mind? They have come across few best algorithms. These are the ones. Okay, the first one you're going to learn it. I think UNS algorithm will be the basics for all the algorithms that you see down. Okay, so the UNS algorithm is like the basement. That's the reason it's written one of the earliest algorithms, UNS algorithm. In UNS algorithm, what is going to happen in video? They are going to please explain UNS algorithm with example. Okay, explain UNS algorithm or classification based on UNS algorithm with example. However they ask, whatever they ask. Two things to be kept in mind. Number one, what is your training data? Training data input should be there. Number two, going to write the algorithm. Number three, going to write the solution for it, step-by-step solution. Can you do all the three? Yes. If you do all the three, whatever that 8 to 10 marks that is sort of allotted to it, you will be getting it. Okay. Then the next one, if they themselves give you the training data, okay, then you should be able to apply that algorithm and get the solution, just like what we did for your A Pro A and your FP growth algorithm. So both the things we are going to see. Okay, I want you people to learn this a little bit deeper because the next few topics are a little bit theory only. Okay, the categorization, what is nominal attribute, all those attributes which we are going to read, those things will be done very fast. Okay, but little things which becomes very important for the next semesters, those things need to be studied a little bit deeper. Okay, so it will help. Okay, otherwise the purpose of subject will be only to sort of pass the subject, which doesn't make any sense, right? So UNS algorithm was the very first algorithm. ID3 algorithm is the next very important algorithm, the very famous algorithm. Okay, decision tree based algorithm. Okay, it's again a lab program. I don't know whether the next syllabus which you people are going to study. Okay, but your seniors, everyone used to have that as a lab program in machine learning lab. Okay, so you people belong to 18 scheme. So there's a combination of AI and ML learned. So I don't know. I've not seen the program list. Probably it may be there. Okay, if it's there, good. If it's not there, please learn. Extra program, please learn. Okay, all the programs will be done in your Python. Okay, so make sure that you people are learning it. Now, what is the next thing? Okay, all these algorithms, one UNS, ID3, C4.5. Okay, successor of ID3 and all. Then you got CART. What is CART? Classification and regression tree. What is regression? You're going to learn a lot of things related to regression in 7-7. Okay, then you have called CAD. Okay, CAD or KIDE something, however you pronounce it. What is more important is to know what is the full form. Okay, it's called chi-square automatic interaction detection. Okay, then you have mass, multivariate adaptive regression splines. I don't know much about these last two things. Okay, CAD and mass, because this is there in your textbook. Even I have not gone into it. Okay, the 1, 2, 3, the UNS ID3 C4.5. C4 find also very less, but just know the basics of it. But UNS and ID3 algorithms are the most things which you need to know. Okay, let's go into the next part of it. Okay, what are the things to be kept in mind here? Before we move into this, let me sort of go and show you what is the UNS algorithm. Okay, where is my UNS algorithm? For this, what is the example to be taken? We are going to take, see, this is a textbook. Okay, it's a textbook I've taken right from the textbook itself, because I want to copy that and put it there. Okay, we'll be doing it, but I want, before that, I want to put it in very simple words. I want to, I was doing that, but the time got over. So with regard to your class, okay, now just look into this. Okay, what is the thing to be done? If you don't understand, don't worry. We are going to put this algorithm in very simple words which you people will understand. Okay, so what is UNS algorithm? It's a decision tree. Okay, grown recursively. Recursively means you're doing one step after other. Okay, by partitioning the training records into successfully purer subsets. I tell you what is an example you need to keep in mind. You keep in mind with regard to this example. The example what you saw here, where is it? Once again. This one. Yeah, this one. Yeah, this one. This you got to keep in mind. You keep this example in mind, you got an entire thing with regard to your UNS algorithm. Okay, so let's look into that. Okay, what does it say? Let dt, what is dt? T will be representing your data. Okay, T will be representing your test set, data test set. These are set of training records that are associated with the node T. Okay, node T, and with y is equal to y1. Okay, don't worry about that. I'm just going to sort of come back. Okay, with very simple words next time. So don't worry. Okay, the following is a recursive definition. Okay, fine. If all the records in dt belong to the same class yt, then T is the leaf node labeled as yt. Okay, what is the meaning of that? Don't have to worry. Okay, then if dt contains records that belong to more than one class, okay, here it is all same class. You can see very clearly it's all same class here. But if it is here more than one class, what you are trying to do? Attribute test condition is selected. What is that? To partition the records into smaller subsets. A child node is created for each outcome of the test condition, and dt are, you can see very clearly, okay, in dt are distributed to the children based on the outcomes. Okay, so this, what is this? Probably you would not have understood. And what is this? You know this very clearly. This is again the same old example of what we studied. Okay, the example of what we studied, the same thing is again coming back. Using this only, I told you that we are going to do what is known as the algorithm of Hunt. Okay, so let me take this example. Okay, and let me do it. Okay, step by step, we'll see that. To illustrate our algorithm should consider the problem of predicting whether a loan applicant will repay the loan obligations or become delinquent. You see this, these words, right? You see this, in words, and you know what is all this under. Okay, delinquent means the person who is not going to repay his loan. Okay, so that's a meaning of it. So only I tell you, don't read the textbook, you will go mad. Read textbooks only if you are interested in it. For the VTU purpose, don't read it. Okay, as simple as that. I am a very big fan of reading textbooks only when you don't have to worry about the VTU part. Okay, or the other way of looking at it, you read the textbook, you will not understand a few things. Come back to notes, you will get to know everything. Or read the notes, you will feel okay with it. Then go back to textbooks to gain more knowledge about it. Okay, two ways also it will work. But don't just read the textbook and go into exam, then it will not be a right one. Okay, because you got to be smart to clear the video exams. Okay, next. So what is the way you need to do this? Okay, very simple example. We are going to take the same old example we are going to take. So initially what you are going to do is, see this The initial tree for the classification problem, what does it contain? It contains a single node. What is that single node? With a label claiming defaulted is equal to no. So first thing that you're going to look for here is this one. Okay, you're going to take this whether the particular defaulted is no or yes or no. We are going to say no because by default we are saying that people will repay their loans by default. Okay, we are hoping and thinking that majority of them will be repaying that loan. So you're going to start with default, equal to no. Then we move into the next part. You can see very clearly says here, which means that most of the borrowers successfully repaid their loans. That's what we think. Next, the tree, however, needs to be refined since the root node contains records from both our classes. Okay, so because we have two people also. What are two people? You can see that example right here. Or else I'll show you here. Okay, so it's easy. It becomes easy. See this? You got people from two classes also. What are two classes? People who pay everything. No, no, no. Defaulted borrower. No, no, no. But there is one few set of people who will not be paying the loan. So defaulted borrower, yes. Okay, you see this X. Yes. Okay, then you have one more S. You have one more S. So you have, two sets of people here. Because we have two sets of people, the root node contains records from both the classes. So you need to go for the refining part of it. Needs to be refined since the root node contains records from both the classes. Okay, so what do you do based on? The records are subsequently, because of this, the records are subsequently divided into smaller subsets based on the outcome of homeowner test condition. Okay, so based on homeowner test condition, we are going to do this. Now, why we are going to do that? You may be asking, okay, why we are, where is it? Yeah. This is only our example, right? See, based on homeowner condition, we are going to sort of look into it. Now, some people may be asking why is doing it? Why not in other condition? Why only on home condition? The answer is quite simple. What is that simplest of answer we can see? If you look into homeowner, okay, whenever the homeowner is yes, is never a default borrower. Okay, so you come across only two binary values. If the homeowner is yes, is never a default borrower. Check here. Homeowner yes, default borrower no. Homeowner yes, default borrower no. Homeowner yes, default borrower no. Okay, whereas in this case of no, homeowner no. Okay, default borrower no, no, no. What about here? You can see this homeowner no, default borrower yes. Okay, so that's a sort of explanation that's been given here. The justification for choosing this attributes condition will be discussed later. What is that later? Is nothing but figuring out how it is came through. Okay, now from that, what is the thing that we can see? Homeowner. You see this homeowner. If it is yes, when we say defaulted borrower is no. If it is no, we say defaulted borrower is no. Okay, so based on that, we'll be keep on creating aspects like this. Okay, you can see one more thing that is going to come here. Okay, once you see this, for now we'll be assuming that that's the best criteria for splitting read. Okay, next, Hunt's algorithm is then applied recursively to each child node of the root node. So what is child node of the root node here? Okay, child node of the root node is whether homeowner yes or no. If is yes, you can see very clearly here. If is yes. Okay, is it defaulted? No, that's the end of it. So the child node ends here towards the left hand side, but the right hand side you go for marital status. Okay, you go for marital status to figure out whether he's single or married or divorced or married. Single and divorced people have a very good probability that they become default. Okay, married people no. Then once you figure out those two, you have one more fields also. What is with regard to the income? So you based on that also you do annual income. Okay, less than 80k. Greater than equal to 80k. You say defaulted. Okay, sorry, less than equal to 80k. You say defaulted, yes. More than 80k, defaulted, no. Okay, he's got more money, even though he's married, he's got more money, so he'll be repaying his loans. Okay, now this is how you are going to do what is known as recursively doing it. Hunt's algorithm, from the training set data, you can see very clearly all borrowers who are homeowners successfully repaid their loans. The left child of the root is therefore a leaf node labeled defaulted is equal to no. But the right child, we need to keep on paying the recursive steps of Hunt's algorithm until what? Until all records belong to the same class. Now you check. Do you all the records belong to same class here? Yes. Either you can see this marital status, yes or no, like that. Okay, all records belong to the same class. The trees resulting from it is basically here. We have seen this, okay, as example here itself. Example for a decision tree. So this should not be a problem to you. This should not be complex to you. But will it end here? No. We are going to take one more example. Okay, where the tree is not there. Here the tree is already there. Okay, tree is already there, so everyone can be doing everything here. Okay, in the next step, what we are going to do is we are going to take those things where the only training data will be there and the tree is not there. And then we'll be trying to figure out a tree for it based on unsolved. Okay, I think that we'll be doing in the next class. Okay, at least we'll take one example with regard to unsolved algorithm. Then we'll be moving into the theory part of classifying the types of classifiers on. Okay, very simple things. The one important thing that you got to keep in mind is these diagrams need to be written very clearly. Neatly you can write. You have to write neatly. Otherwise the marks will not come. Neatly you have to write diagrams and it becomes easy. Okay, once you do once or twice it becomes easy. Writing diagrams, memory diagrams and all. Okay, then it will not be a problem. Okay, in the next class we'll meet and we'll talk about one more Hunt's algorithm example and then we'll be moving into the theory.